for the product rule.
But there's no numbers in this file.
So we learned the sum and difference rule last week, which meant that if you're adding two things, you could just take the derivative of them separately. So then, mathematicians, including one of the greatest ones in calculus, Leibniz, was like, well, what happens if you're multiplying two things? If adding them just says take the derivative separately, what do you think we should do for multiplying? Can we just take the derivative of them separately when we multiply? And that is the most common sense thing that you would like to do. And that's what Leibniz wanted to say and try and do at first. And it fails utterly. And you can see that it fails if you take something like x times x to the 4, which is obviously x to the 5. You already know the derivative of x to the 5 with our power rule is 5x to the 4. But if we tried to do it separately with x and x to the 4, and we found the derivative of x is 1 and the derivative of x to the 4 is 4x cubed, and we multiplied those together, we have a problem. It does not match.
I agree.
And here we get like the first very complicated shortcut in math, which is the product rule. Sometimes in university, they ask you to prove the product rule. The product rule unintuitively shows up like this, and I find this really helpful if I also use colors. So if you have one function which I highlight in yellow, multiplied by another function that I highlight in green. To get the answer, what you need to do is first, just keep the first one the same, don't do anything to it, and multiply by the derivative of the second one. And then keep the second one the same, and multiply by the derivative of the first one. So you keep one the same, multiply by the derivative of the other one, then keep the other one the same, and multiply by the derivative of the first one. And it doesn't matter which one you keep, because you're adding, it doesn't matter which one you decide to keep the same first. Keep one the same, multiply by the derivative of the other one, then keep the other one the same, and multiply by the derivative of the first one. In the first part, I've got Newton's notation with the little prime marks. In the second one here, if you have a function u times a function v, you keep the u the same, and this is Leibniz notation. dv dx is the derivative notation for Leibniz. And then keep the second one the same, and multiply by the derivative of the first one. And the product rule is like, as a shortcut in math, once you know, it's like the cheat code. Once you know the cheat code, it's really quite easy to do the question. But anybody who doesn't know the cheat code and sees you write the answer down, they look at you like, what just happened? So I'm going to go back one screen. This is my first function. This is my second function. And I'm multiplying them together. If I want to find the derivative of this, I can write the answer right away. And if someone was watching me, they'd be like, oh yeah, I can do this. It's going to be, this is the answer. And they'd be like, what the heck are you doing? You can just quickly write the answer down. What did I do? Do you see that I kept the first one? Oh, that's the wrong color. So bad. Let's go quickly erase it. Yellow. I kept that first one the same. What's the derivative of the green one? 2x minus 5. Then I kept the second one the same. What's the derivative of the yellow one? You see that it's 3x squared plus 3? And the nice thing about derivatives is you do not need to simplify. This is the final answer. In fact, we are going to be doing highly complicated math, and for a lot of situations, you can write the answer down immediately from the question without having to show any other work. You haven't done that like since grade 9, where you can just like in grade 9, sometimes they had like x plus 3 equals 7, and you could just write x equals 4 and go on to the next question, not have to show any work whatsoever. Calculus's shortcuts has gotten us back to that. But they make you look impressive, because if someone doesn't know calculus, you'd be like, oh, you want the derivative? Here it is. You'd be like, what? Oh, it's very complicated. You just don't tell them the shortcuts. Don't tell them the secret. Just looks really impressive when you do it. This is your product rule. And you'll see me say this in the words that I've highlighted here. In other words, the derivative of a product is the first as it is times the derivative of the second. I often just say keep the first the same times the derivative of the second. Then keep the second the same times the derivative of the first. That is your product rule. It can be proven using Newton's quotient and doing the limit as h goes to 0. Whew. And some of you might want to look up the proof. Some of you, if you retake calculus in university, your professor might show you the proof, and you'd be expected maybe to show it on a test or an exam. I actually have, somewhere in here, I have my first year calculus midterm, and that proof is on there. So they gave it to me.
Did you get it
I
right?
got it right. I think. I can show you. But I'm pretty sure I got it right, because I remember my mark on the exam. Okay. What do we do here? Again, do we have a product rule? Yes. This is the first. This is the second. Do we have to use the product rule? No. Why? Could you multiply that out? If you multiplied it out, it would be really easy. But I'll show you both. Okay? So 1, I could keep the first the same times the derivative of the second, plus keep the second the same times the derivative of the first. And on an exam, no simplification would be necessary, unless this was a multiple choice question. Because what do they do in multiple choice? They often simplify things. So if you wanted to, you could multiply it out, combine your like terms, and get that. Can you see that if, oh, actually I don't even want you to write that. I know what I'll do. I'll go back. I do want you to write this down. If you distributed this x squared, you see that you would get 2x cubed minus x squared. And now you have your regular shortcuts, your product rule that you could use. What would the derivative be? 6x squared minus 2x. In this example, I actually like the black better. I think it's quite easy to multiply it out and then just use our first shortcuts. However, it's nice to see that if I had highlighted it before, keep the first the same, derivative of the second, keep the second the same, derivative of the first, works out fine as well. So when do we like to actually multiply it out? And when do we like to use the product rule? Well, if multiplying it out is a lot of work, then you're like, I want to use the product rule. If multiplying, like this one, it was not much work to multiply it out. I like that better. Could I multiply this out? Yes. Does it look a little annoying to multiply out? Yes. So what might I want to do is I might want to say, this is my first one, times by this is my second one. In order to use the product rule, there needs to be a multiplication between two things, a product. Brilliant how they named it the product rule, and you need a product in order for it to work. Someone was thinking. If that's the case, what can you do? You can keep the first one the same. There it is. Like, oh, that's not. It's been really struggling. I wanted to check the yellow one first. There we go. Keep the first one the same. Multiply by the derivative of the green one, which is just 2. Then keep the second one the same. And multiply by the derivative of the first one. You're like, if there's a product rule, does that mean there's a quotient rule? Mm-hmm. We're going to get there. Maybe we'll leave that for tomorrow. And if you wanted to, you could simplify this. No, I wouldn't recommend it. I would actually be like, more than happy if you left your answer like this. Okay? If you wanted to multiply that out, you could. This is what you would get if you multiplied it out. And if you multiplied it out first and then took the derivative, you would get exactly the same answer. This one's not hard to multiply out. It's just foiling, doing your distributive property. It's not bad. But you will start to get some where you're like, ugh, I really don't want to multiply that out. So therefore, the product rule becomes a lot nicer. Let's go to the next one. I think this one would be one I would not want to multiply out. But I might do a little bit of thinking. Like this is, it says find the derivative of, I take out my highlighter. There's my first one. Definitely got multiplication, so I can use my product rule. Here's my second one. And off to the side, as a preliminary little step, what can you do with this? Oops, it's not. It's just a square root. X cubed inside. You're going to have to think like that. So what do? Find the derivative. We keep. Highlighter out again. We keep the first one the same. So I've already changed that cube root of x to x to the 3 halves there. Derivative of the green one is going to be 0 plus 10x. So I just wrote 10x. Then I kept my second one the same. How do I do the derivative of x to the 3 halves? Well, the 3 halves would come out in front, subtract 1 from the exponent. And the derivative of x is just 1. What is starting to happen is we are learning a couple of shortcuts. And the expectation is that you're really good at those shortcuts because the next shortcut uses the previous shortcuts inside of it. Can you even imagine doing Newton's quotient for this one? Look at all the x plus h's you'd have to plug in for every x. And then you'd have to figure out some sort of algebra to make it simplify. It would be really not very nice. The shortcuts are way nicer. Again, I would leave my answer as that. If you multiplied it out, you could get this. And then if I took the derivative of each one separately, you would get that. I'm going to tell you, and you just have to trust me, that simplifying the top one would give you the same thing. But you're often not needed to simplify them. Only times are multiple choice questions. So now you have two different options. You can use the product rule, which most people like to use because it means they don't have to simplify first. And because you don't have to write your answer in simplified form, you would just leave it like that, is really, really nice. Or you could multiply it out first and find your derivative afterwards. Sometimes what's hard in the product rule is just seeing the product and what's the first one and what's the second one. And I think that's a little bit like that in this question. Because when you have two brackets beside each other, it's really obvious that it's this one times this one. But when you just have things mashed together like this, I need a product. Where would I put that red dot? Because technically, the red dot could be here, right? That's a product. Or I could put it here. That's a product. Or should I put two red dots and have two products? What should I do? Okay. I would put, so that red dot, what you want is you want your one function to be something you can do the derivative of, and your second function to be something you can do the derivative of. So it makes sense to do 7 root x and e to the x. And that 7 root x, I would take the extra time and change it. I'll highlight these again. Here's my e to the x. My first one is actually 7x to the half. There is no way that we can simplify this to use our previous shortcuts. We have to use our product rule. So what does a product rule say? Keep the first one the same. There it is, keep the first one the same. And this is where your brain starts to go like, oh my goodness, I have to, in this, I kept the first one the same. And I changed the second one to exactly the same as it was. Because the derivative of e to the x is e to the x. Can you see that, your brain not liking this? Because the product rules keep one the same, derivative of the second one. But in this case, the derivative of the second one is also keeping it the same. And then keep the second one the same, and derivative of the first one. Which afterwards, if you wanted to simplify, you could. And if you had to add those, like if this was multiple choice, they might get you to get a common denominator and add those fractions together. They might get you to rationalize the denominator. So all of the stuff that we do in our labs, which practices your previous stuff that you've learned, is mainly to help you with the multiple choice where they're like, I'm glad you can do the calculus, can you still do your grade 9, 10, 11 math? And they'll rearrange this. Right? Because if I wanted to add these together, you see that this is over 1. So I would need a common denominator to add fractions. So I'd have to multiply by 2 root x and 2 root x to get that common denominator. And then I can make this equal to all over 2 root x. What would I get? Well, this will be 14x e to the x plus 7 e to the x. They might do that. They might also say, oh, do you remember in grade 11 you weren't allowed to have square roots on the bottom? How would I get rid of that square root on the bottom? I'd have to multiply the top by the square root of x and the bottom by the square root of x. What would I get? Well, then I would get 14x square root of x e to the x plus 7 square root of x e to the x over 2x. That might be the answer in the multiple choice. What else could they possibly do to this question?
We can factor out the.
Right. They could factor out, they could factor out even this part of it, right? That's in common, so they could put that in front. There's lots of options for manipulating these things, and you'll start to see that when you do questions. Whether you do them out of the textbook or when you do them on take-home quizzes, we'll have multiple choice questions where you get the first answer, and then you still have to manipulate. It's kind of like a mini identity to make them match up. Okay, we'll do one more question. Because we haven't done enough questions with the natural log. I'm going to add one more. You can try this one on your own. I'll give you one more. Here, we'll do that one as well. And you could leave it like this. If you wanted to simplify the x squared with the x on the bottom and just get 3x, you could. So we keep the first one the same, and the derivative of natural log is 1 over x. And we keep the second one the same, and the derivative of 3x squared is 6x. And the last one here. Second one, there's my first one. F prime of x would be keep first one the same, multiplied by the derivative of the second one, plus keep the second one the same. And what's the derivative of 5 to the x? To the x natural log of 5. So again, we kept this one the same. Derivative of the second, then kept the second one the same. Derivative of the first. So today was a big day because you learned 1, 2, 3, 4 new shortcuts. You learned the shortcut for e to the x, doesn't change. You learned the shortcut for any other number to the x, 5 to the x, 10 to the x, 7 to the x. You learned the shortcut for natural log of x. And you also learned the shortcut for the product of two things.